வணக்கம். ஒவ்வொரு மாதமும் முதல் சனிக்கிழமை ஃபர்ஸ்ட் சாட்டர்டே இந்த தமிழ் பாரம்பரிய அறக்கட்டளை சார்பாக இங்கே தக்கர் பாபா வித்யாலயாவில் வினோபா ஹாலில் நம்ம லெக்சர் ஒன்று ஆர்கனைஸ் பண்ணிட்டு இருக்கோம். ஜென்ரலி அபவுட் தமிழ் ஹெரிட்டேஜ், பட் அதுலேருந்து கொஞ்சம் எக்ஸ்டெண்ட் ஆகி பிற துறைகள்லையும் பண்ணியிருக்கோம். ஒழுங்காக கவுண்ட் கூட வச்சுருக்கேன். நியர்லி 25 months கண்டினியூஸாக பண்ணியிருக்கோம். அது கரெக்டாக சார் 25, 26 கூட ஆயிருந்தாலும் எனக்கு தெரியல. திஸ் இஸ் 26. ஸோ அது ஒரு பெரிய ஒரு லேண்ட்மார்க். ஆக்சுவலாக இந்த மாதிரி ஒரு மைல்ஸ்டோன் 25 இன் சக்ஸஷன். அதில் லாஸ்ட் ஃபியூனா அட்லீஸ்ட் ஒரு 15+ ஃபுல் வீடியோவே வி ஹேவ். ஸோ யாருனாலும் அதை பார்த்துக்கலாம். ஃபஸ்ட்டு 10 days சிலதில் ஆடியோ இருக்குது. அதை வில் somehow organize that. நான் வீடியோலாம் ஐ எம் ஆடிங் இட் ஆன் டு யூடியூப். ஸோ எவ்ரிதிங் இஸ் அவைலபிள். அதில் 3 months முன்னாடி நவம்பரில் கோபு கேவ் இந்த இந்தியன் அஸ்ட்ரானமி ஃபர்ஸ்ட் பார்ட், ஒரு ஃபேர்லி அவுட்ஸ்டாண்டிங் ஒன், நியர்லி 2 hours போனது. அடுத்த மாதமே அதோடைய செகண்ட் பார்ட் இருக்கிறதா இருந்தது. பட் தேர் வேர் ஃபியூ இன்டரப்ஷன்ஸ் பிகாஸ் வேற சில முக்கியமானவங்க வந்த உடனே இவர் வந்து இவருடைய குரூப்லேயே இருக்கிறதுனால கொஞ்சம் அவருடைய இடத்த வாங்கி மற்றவங்களுக்கு கொடுத்து அதெல்லாம் நடுவில் லாஸ்ட் 2-3 months வேற நடந்தது. ஸோ அதோடைய செகண்ட் பார்ட் ஆஃப் தி இந்தியன் அஸ்ட்ரானமி அதான் இந்தியன் அஸ்ட்ரானமியோடைய that's the larger idea. Yes. True.
Thanks for the introduction. Some of you, I think, at least attended my last lecture. Some of you have new faces here. My last lecture was perhaps easier to digest because I was talking about the Mayas and the Egyptians and the Sumerians and the Babylonians, whom we learned very little about except a few pyramids and some things like that, or human sacrifices and things like that. So that they had signs and I had a lot of visuals to show. This lecture about Indian astronomy is going to be slightly more conceptual. I expect to disappoint most of you, in fact all of you, but I expect to disappoint each person in a different way. And probably because the subject is so huge. Indian astronomy, not just Indian astronomy, but astronomy in general is such a huge subject. It's not really possible to do any justice to it in any single lecture. And I set myself an ambitious target. The last lecture that I gave was supposed to be a 10-minute introduction to the rest of it, and that ballooned into 90 minutes or so. And I left out most things because it's not possible to digest that. This time, equally ambitious, I think, but we'll see how it goes. I think a lot of you will learn things that you think you knew are really something else. So that would probably be the interesting experience. If you're anybody who is an astronomer, please reserve your comments for the end of the lecture. I first like to thank a few people because I forgot to do that last time. And I start with K.V. Sharma. This book was given to me. This collection of articles by Professor K.V. Sharma, Facets of Indian Astronomy. There's plenty of Indian astronomical text. It's not like he invented it or anything. But this is such a beautiful introduction to astronomy, such a way to centrally learn about it. Professor Swaminathan gave it to me. And Dr. Devadas, who conducted a course at the planetarium here. And I spent some time 5 years back learning about it and I learned some concepts. The third is Professor Swaminathan for giving me this opportunity. And not just for the opportunity of presenting, but the inducement to learn about astronomy and see what a vast subject it is. And I thought I knew some aspects of it. I found out how much I didn't know. I give Professor Swaminathan credit for expanding the sphere of my ignorance. The more I meet with him, the more I realize how ignorant I am. So, fourth is to Mr. V.S.S. Iyer, who helped me with several copies of books, including the 2 astronomy books here, and he gave me online copies of the Aryabhatiyam, the Surya Siddhanta, the Varaha Mihira's Pancha Siddhantika, Varaha Mihira's Brihad Samhita, Brihad Jatak. I didn't read most of those. I browsed through them. And finally, my brother Jairam, on whom I beta tested both my presentations. And that fact is both my presentations. And he thinks it's twice. I did it once, but he feels like I did it twice. So, anyway, I would like to show you some sources because almost none of this is any original thing for me. Get this from me later. This is just my giving myself a license to make mistakes. That's all. I'm not an astronomer. I'm not a mathematician. I'm not an astrologer. I don't know Sanskrit. I only read English translations and commentaries of a very small part of the words, and only small parts of those. To give you an understanding of how much astronomical text we have, I think just the astronomical number of people who have written books on astronomy will surpass the number of people who have written Ramayanas. I'm not kidding. And the number of people who have written commentaries will surpass the number of people who have written commentaries on the Ramayanas. That is how vast a collection there is on astronomy in India, mostly in OLHUD and then publications and paper and all kinds of things. One question which people might have is, why am I talking about Indian astronomy in Tamil Paramparya? There is supposed to be a lecture about Tamil Paramparya, a series of. There is a misconception that only art and dance and culture are part of our literature, are part of our heritage. Science is too. And astronomy is very, very, very deeply part of our culture. Even if you ignore it as a science, it's very deeply part of our culture. So I think it's very appropriate. This is the outline of the lecture. I'm not going to. This is kind of a guideline for me. These are the landmarks of Indian astronomy. I'm going to stop before the invention of the telescope, or roughly around that time. I'm going to stop around the time of the telescope, invention of the telescope. We start with the Vedas. As with almost anything else in India, if we start our subject, we have to start with the Vedas. Then we go to Vedanta Jyotisa, which is slightly an offshoot of the Vedas or an attachment. I am not going to talk about Buddhism this time, just a little one slide about Jain astronomy. I'll talk about 18 Siddhantas. I'll list you the 18 Siddhantas, but I'm only going to give you glimpses of one. Then the other landmark of astronomy is the invasion of Alexander or the Hellenic Empire. We don't think of empires, civilization, conquest as impacting science, but it does. And one of the one we know is, of course, British colonialism, the invasion of the British. But this is also a significant hallmark in the invasion in the history of astronomy. Then we come to what people consider the scientific era of Indian astronomy, starting with Aryabhatta, then going through Varahamihira, Brahmagupta, and a whole bunch of others. Then we have the people who learned from us, Al-Khwarizmi, Al-Biruni, the Muslim and Arab astronomers. Another important person is Genghis Khan. We don't think of Genghis Khan as a civilizing factor or as a man, but he created an empire from the Pacific Ocean to the Mediterranean Sea. That had its impact. He was the one who took Chinese secrets out of China, Iranian secrets out of Iran, Arab secrets out of, and he amalgamated all of them. He was the first Asian globalizer, if you could call him that. And I'm not going to talk about it, I'm just mentioning the landmarks. Then we come to the next revolution in Indian astronomy by Indians, which is by Parameshwara, who started something called the Trik Ganita, and Nilakanta Somayaji, who followed up on that. Then, of course, we have Galileo, Copernicus, the invention of the telescope, the European civilization. That's fairly well known to us. It's the part before that probably you are unfamiliar with. What revolutionized astronomy? And most of us will say, obviously, the telescope. What we could see with the telescope is substantially different. What we can understand before the telescope, not the telescope, are massively different. And that's true. But it's not the only instrument, and you should not consider only instruments as things that affect astronomy. Paper is major. We take paper for granted. Paper is something that advances civilization, but specifically it also advances astronomy. The ability to record massive amounts of information and show us clay tablets. We think of clay tablets simply for writing, but astronomy requires vast amounts of record keeping to see patterns and all that stuff. This is the basic of science. You look at a bunch of data, you see the commonalities, you see patterns, then you come with inference theorems and so on. So paper and clay tablets, just as much as palm leaves and things like that, are important revolutions in astronomy. And the decimal number system was a huge upheaval. Europeans' Renaissance and science progress of science was very comparatively slow before they adopted it. The world has adopted. We think of the world being colonized by the English language today, or by some cultural aspects of music. But the decimal English language has colonized maybe about 500 million people. The decimal number system has colonized everything. Everybody uses decimal system. Nobody uses any of the old number systems anymore, except as a ceremonial or a stylistic thing. And the positional zero was a massive improvement, massive innovation. Geometry and trigonometry. We think of, because we learned math in one shot, we don't think of geometry and trigonometry as advances. At one point, the Mayas were probably the only people who did astronomy without much trigonometry and extremely little geometry. And so that's also very important. These are also things that algebra. We think entirely algebraically in math now. But algebra really came about only in the 13th century in the notational form that we understand. The Indian mathematics, the number system all went to the Muslim countries, Arabia. Astronomers went to Baghdad, to the Caliphate of Al-Mamun. And he invited astronomers from India and they learned things. The Siddhantas of India are pronounced as Sindhins in Arabic culture, and they got it from there. The Westerners, Fibonacci, the Italian traders, the merchant marine city-states borrowed the number system from Arabian number system. We think of Fibonacci as the man who invented the Fibonacci series, but he introduced the number system, the decimal number system, and the place value system to Europe. Massive revolution since then. And not to mention the even later additions of electricity, nuclear physics, quantum theory, and so on, which have all revolutionized astronomy. And of course, the most important thing is to have an open mind. And as you repeatedly see that scientists are supposed to have an open mind, they don't always do that. The Indian calendar. Astronomy, mathematics, calendars, and astrology are very closely related. You can't separate one from the other. They are very tightly integrated. The Indian calendar, I'm going to mention it. It's, some use the lunar calendar like Islam and China. Others use the solar calendar. Egypt used to be effectively today have a solar calendar. We use zodiac. The zodiac is Babylonian. The 12 Rashis come from Babylonia. The Rishabha, Mithuna, all these Lagnas, all that come. They are adaptations from Babylon via Greece and Rome. Some use multiple calendars. Mayas and Aztecs used a religious calendar and a 365-day calendar simultaneously, the 260-day religious calendar. Some have reformed their calendars. The Gregorian calendar is reformed, the Julian, which is a reform of the previous one. Some have kept what we would consider a flawed calendar. So what have the Indians done? Everything. We didn't abandon anything, we just kept everything. And more. We had things besides these things. And so we kept those also. So I will talk about it. I'll start with the Vedas. There is a great plurality in Vedic thought. The Vedas are not composed by or compiled by any one person, or in one place, or in one time, or in one age. The general geographic area seems to be from the Himalayas to the Vindhyas. I don't know what the western eastern range is. This seems to be the substantial portion of the compilation of the Vedas. Different people, different times, different eras. Plurality of authors, a plurality of subjects, a plurality of ideas, opinions, often tangential. They don't always agree. Sometimes conflicting. We have heard in our mythology conflicts between Vasishtha and Vishwamitra. We have heard Bhrigu fight with pretty much everybody else, including Mahavishnu. We have heard Durvasa, he has a reputation for troublemaking. So, and these are all rishis. You don't belittle somebody because they have different opinion. And the Vedic period is, the literature of that period is a mix of imagination, observation, and apathy. Some things they just seem to have made up. They say the world comes from water, water comes from sun, the sun comes from... Different people have different ideas. Some people say this comes from this, that comes from that. Observation, there have been observations, though not very extensive. And some have simply not cared. They have not cared about this thing, they are contemplating or meditating. A very interesting observation in one of the Vedas, I think this is from the Rig Veda, is that the stars are large but seem small because of their extraordinary distance. This is a very interesting observation made a very, very long time ago. The Saptarshi and the Kritika constellations are mentioned. Important factor to know is the numbers in the Vedas are in the decimal system. So we have had the Vedas since that time. One of the issues is that modern science teaches us, or modern historians teach us, that the Vedas are probably datable to around 1500 BC, because they say it's after the Indus Valley civilization. This was done at this time. The Vedangas come later. The Mahabharata, some people will date to the they say it happened in the 8th or the 7th century BC, and it was recorded in the 4th century BC to the 2nd century AD. And all this is modern historian things. You'll have a lot of conflicting ideas about all these things, and I might refute some of this. There seems to be historic evidence to refute some of these things, and you can take them or leave them as well. The Vedas are the time when we already have Tithis and Nakshatras. We know the Tithis as the days of the moon, the Pratama, Dvitiya, Tritiya, Chaturthi, Panchami, Shashti, and so on, up to Amavasya. And again, same for the Krishna Paksha and the Shukla Paksha, we have the two Tithis. But in the Vedic time, the Krishna Paksha and the Shukla Paksha, the Tithis apparently each had a name. And they had different names in the morning and different names in the night. I have a list of 60 names. I don't want to flood the screen with all kinds of information. So one of the difficulties I had with this presentation was what to leave and what to keep out. I had to try to go for the flavor and cut out some of the extra information, because it may just be too much to absorb. So one of the interesting stories that you have, and the other aspect of Indian history is we find it very difficult. Itihasa means this happened thus. Charitra means what happened, what walked. And we see that it's a mix of fact, fable, and some things are allusions or allegories. And we can't separate which is which. Some things look like fable, some things look like fact, something looks like allusion, which is which. And there, I'm going to talk a little about Vishwamitra. Vishwamitra is apparently called the Nutana Shrishti Karta, the inventor of new things. So he was not just a man who's spiritual or a person who did yagnas. He was also a great thinker. And the Trishanku, one of the famous stories is of Vishwamitra. Trishanku, a mortal, wants to go to heaven directly before death. Vishwamitra uses this, basically Vasishtha says no. Vishwamitra says, I use my tapasya power to elevate you. Indra says, no, you can't come down there. And so he's suspended in mid-heaven. And this we hear as fable. Let's say, some elevation, this thing, mythology. Now, Trishanku in the Indian system is the constellation Centaurus. Centaurus is the closest set of stars to the solar system. The closest star is called Proxima Centauri. It is the closest one. And all the other stars are much farther away. I wonder where the fable is and where the fact is here. Or it's just an allusion. Which came first, this or that? I thought it was interesting. The second thing that we hear is about the march of Agastya. Agastya marched from the north, came down south, crossed the Vindhyas, told the Vindhyas to stay, and then the Vindhyas wouldn't grow anymore. And then Agastya did all kinds of wonders in the south and all that stuff. Now, Agastya is the name for a star that the Westerners call Canopus. And we don't really have a true southern pole star, but it's a kind of a circumpolar star. It's very close to being the pole star of the South Pole. This is the second brightest star in our sky. We can't see it normally in the northern hemisphere, you can see it in the southern hemisphere. And for a long time, the people in the Aryavrata, the area from the Himalayas to the Vindhyas, could not see the star. Something happened, probably a tilt of the earth axis, something different, I don't know what. And suddenly one day, the second brightest star in the sky was visible. The brightest star is Sirius. And the second brightest star, Agastya, was visible. And you could see it over the Vindhyas. So until that point, the Vindhyas are hiding. Now, where is the fact, where is the allusion or the allegory here? I think it's somewhat interesting. And Varahamihira, who comes a lot later, waxes eloquent on Agastya. He says, the mighty ocean whose waters were swallowed by Agastya exhibited gems that exhibited the splendor of the crowns of the Devas, and rocks broken by the action of the sharks on them, presented an appearance beautiful though without. And this is paragraph 1. He goes on for about 15 paragraphs. I just selected a couple. When star Canopus, and this is the English translation, so that when Agastya reappears after its conjunction with the sun, waters muddled by their contact with the earth will resume their original clearness, just in the same way as the minds of the sadhus naturally recover their original purity after contact with the wicked. And the word they use is a pun word, the contact of the star, and the Sanskrit word for those is the same word. An interesting observation I saw was that if you look at the geography of India, there is nothing but land to the north and nothing but water to the south. And there is a wonder why is this what they meant by Agastya swallowed the oceans? Is it an allusion? Very interesting kind of things that if you look at it. So you can look at the Vedas for astronomy. You can also look at astronomy for fables, fact, and other interesting. This is poetry. This is Varahamira is writing poetry. It's a text on astronomy. So we'll come to the Vedas now. The Vedas are 4: Rig, Yajur, Sama, and Atharva. And there is a bunch of associated texts called the Brahmanas and the Aranyakas. These are called the Upanishads. In the Vedic period itself, there's not that much, but allied with the Vedas are 6 texts that are supposed to be compulsory reading for people who study the Vedas. These are called the Vedantas, the limbs of the Veda. And the 6 divisions are Shiksha, Vyakarna, Chandas, Nirutta, Kalpa, and Jyotisha, which is what I have translated: the phonetics, grammar, poetic meter, etymology, rituals, and astronomy. And since they are Angas, one is called the head, one is called the arm, one is called the chest, one is called the eyes, and so on. And Jyotisha is called astronomy, science of astronomy. Jyotish is light. Jyotisha is studying light, stars. And astronomy is called the head of the Vedantas. And the Vedantas give us a lot of information on Indian astronomy. The Jyotisha Vedanta itself has 3 different receptions. One is attached to the Rig Veda, one to the Yajur Veda, and the third one to the Atharva Veda. And the authorship of the bulk of the Rig and the Yajur Veda recensions is attributed to a rishi called Agada. And the one that is attached to the Atharva is ascribed to a rishi called Bhrigu. And the Jyotisha talks about the nakshatras and the tithis. Nakshatra in general is any star, but in Jyotisha, nakshatras are the 27 stars that we are familiar with: Ashwini, Bharani, Kritika, Rohini, and Margasisha, all the 27 up to Revati that we are very familiar with. Whereas the tithis are, of course, the days of the moon, from the waxing to the waning. And we normally are told that the 27 nakshatras are Kuchela's children, because Kuchela, Sudama had 27 children. Of course, the Vedangas come way before this period. And in the Vedanga, the 27 nakshatras are described as Daksha's daughters. And they all are married to the moon, Chandra. Maybe some of you might be wondering where all the astronomy is coming, because I am talking almost exclusively about favors. It's coming, it's coming. There has also been a utilization of 28 nakshatras at some points, and this is one of, again, like I said, there is a plurality of thoughts, there is a plurality of nakshatras. There is a 28 nakshatra called Abhichit, which is also sometimes called Daksha. And Daksha has started, Daksha has ended. They have used different organizations. For example, Vishwamitra has declared that Shravana is the first nakshatra. We use Ashwini as the nakshatra, right? But our calendar starts where? In April, with the Chitra month. So Aryabhatta came up with Chitra as the start of the months, and so on. So we have very interesting variations also here. And some people even say there are 24 nakshatras and then 3 nakshatras are added, because some of these nakshatras have, like Phalguni, there is a Phalguni and a Uttara Phalguni, and a Bhadrapada and the Uttara Bhadrapada. And so people think that 3 nakshatras were added later for completion. The 24 nakshatras are used. Interestingly, the Chinese also use a 28 nakshatra system in their lunar calendar. They divide the sky into 4 quadrants, 7 nakshatras in each. With 27, it's a very interesting division. You have to divide by 3 or by 9 or by 27. That's it. There's no 4, there's no 2, 4, 6, 8, 5 division. Very interesting. And I'm going to ask you questions, a couple of questions you think about before we get to this. Different New Years start at different times, right? The New Year in the Christian calendar starts on January 1st. The Roman calendar starts on March 1st. April 14th is the Tamil calendar. Some people use Deepavali or the first day of Aipasi as the start of their calendar. So now, all these calendars have the same number of days. The Christian calendar has a leap day every 4th year because of this thing. So where is the leap day in our calendar? How come we are starting on April 14th every time? We don't don't use a leap day in Tamil calendars. There's no leap day. The Marwadis, the Jains, and all these people, they don't use a separate leap day. I'm not going to answer that question. I'm just going to ask you. Second, we always think about sunrise. Think about the concept of a moonrise. You probably haven't noticed it. Sunrise, we think of the start of the day, and you mentally think moonrise is the start of the night. The moon rises at a different time each day. On Purnami, it will rise at sunset because it will be exactly opposite to the sun. On Amavasya, it will rise with the sun. It will be in front of the sun. You can't see it. And every day it goes back 1.5 hours. Effectively, it goes basically what it does is it takes 30 days or 29.5 days to do the 360-degree thing before it comes back again to its original position. So it's very difficult to divide it properly because 360 by 29.5, you do the math. So thirdly, what about star rise? When the night sky rises, there's a whole bunch of stars. And we just assume that, oh, night shows up, the sun goes down, stars come up. But a different star is at a different position each day. Each day, just like the sun moves to the Uttarayana, Dakshinayana, and just like the moon also goes around, the stars also, because the earth goes around the sun, the stars also appear at different times of the day. And that's where you have the zodiac, and that's where you have the nakshatras. If you look at the moon, not just as the moon, but what nakshatra is behind the moon, that cycle of the moon to come back to its original cycle, it takes 27 days. Those are the 27 nakshatras. That is Ashwini, Bharani, so on and so forth. And that is the 27 nakshatras that we use. It's an astronomical phenomenon, not any astrological or nothing to do with Kuchela. The 27 nakshatras are the addresses of the moon per night. But the Purnami to Purnami is 29.5 days. Right? By the way, this nakshatra cycle in English is called sidereal. If the moon is lunar sidereal, if the sun is solar sidereal. Sidereal is the word that they use with respect to the background star. Purnami to Purnami is 29.5 days. Ashwini to Revati is 27, 1/3 of a day. So what happens? So Ashwini to Revati is done, but the moon has only come to the, if it started on Amavasya or Purnami, it has only come to the Trayodasi. There's still 2 days to go because it has to do its 29th part, and it's not even proper 2 days, it's all fractions. And then so it has to go 2 more nakshatras for it to go back to the Purnami or Amavasya position that we started. So there is one discrepancy. Now think of the moon with respect to the earth or the sun as one hand of a clock, and with respect to the stars as a different hand of a clock, moving at different rates. Just like we have one hand moving at 12 hours a day, other hand moving 1 hour, moving in the entire circle per hour. The other, if you have a second hand, it will move every second, and if you have a microsecond hand or whatever you can do. And that's what the moon is doing. If you look at it from Purnami to Purnami, it takes 29.5 days. This is a natural clock. It's almost flawless. It's been the orbital period of the moon from then to now. Almost, we can't tell the difference. That's how small a time difference it's taking. So sunrise to sunrise is what we take off as a day, but it's at 24 hours. In the winter, sun rises at 7 o'clock, 6:30, 6:45. The summer it rises at 5:15, very early. So from sunrise to sunrise is not the constant period through the year. You can't measure that as, you can't use sunrise as a proper clock also, because you will have some problems unless you adjust for the numbers. You can do it on the equinox and then do it on the next equinox and so on. And that's something what they have. The equinox is when the sun is directly over the equator. That's called the equinox, because the day and the night are exactly equal at that time. If it goes to the north, Uttarayana, and hits the Tropic of Cancer, 23.5 degrees latitude north, that is the Tropic of, that's called the summer solstice. And if it goes to the south, December 22nd, and hits the Tropic of Capricorn, or looks like it is hitting the Tropic of Capricorn, then that's the longest night from the northern hemisphere, longest day in the southern hemisphere, and that's called the winter solstice here, and that will be summer solstice in the southern hemisphere. So we have, early on in the Vedic time, they used the lunar month, and they also used the solar month, or the solar year. They roughly realized that the earth goes around the sun in 365 days. They figured that out. They are also using the moon as a calendar. What happens is 12 months and 29.5 days, you get 354 days, 11 short of the actual number. So what happens is, every 3 years you have a discrepancy. You have another 33 days. And every 5 years you have, there's a keep. So what they do is, they used a 5-year cycle and created something called the Adhika Masa. It's called the intercalary month. If you ever read it in English, you call it the intercalary month. So they had a 5-year cycle. And this 5-year cycle is called Yuga. Not the very large Yuga that we think of today. In the Vedic times. This 5-year cycle was called the Yuga. And the Adhika Masa is constantly used, and that was used, and it's still used by some people, I think, even today. So all the astronomy texts talk about the Adhika Masa and how to use it. So this is where the differences come, the complexities come. Unfortunately, I can't do this without math and a few numbers and some minor tweaking and all that stuff. Astronomy is inseparable from math. I try to make things as I want to interest the people who are not very exposed to astronomy or math, and I don't want to bore the people who know a lot and want to see what some extra stuff that hopefully I say. So that's going to be a tricky title. The tropical year is 365 days, 5 hours, 48 minutes, 45 seconds. That's the period from vernal equinox to vernal equinox. So for example, March 22nd sunrise to March 22nd sunrise for the next year is that period. The sidereal year, if you look at the earth facing a particular sun, instead of sunrise from that year to that year, think of star rays from that year to that year. That is slightly different. That comes to 365 days, 6 hours, 9 minutes, 9 seconds. The Gregorian calendar actually uses this. Also, one of the things you have to do is that different people in different parts are living at different latitudes. So what constellations you are seeing, what calculations, they actually make a lot of the common calculations correctly. They understand the traversal of the sun, the Uttarayana, Dakshinayana, they make those calculations, the circulation, all they make. But they see the world from different areas, they see it with different eyes. And so those things matter. There are legacies to geography that impact our history. So, like I said, the Vedic period they used a luni-solar calendar. The moon was called Masakut, the creator of the months. The year was called Sama, Vatsara, Hayana. It was not called Varsha at that point. The Varsha terminology comes much later. And Puranic times, Manusmriti times, all this stuff. It's a later thing. And the Yuga, like I said, is a 5-year period, not the Chaturyuga, Kali, Krita, Dwapara Yuga thing that we know of. At least the Vedic texts that we have do not refer to the Yuga in these terms. These are the nakshatra names. Ashwini, Bharani, I have given a subset of this. The leftmost column here is in Sanskrit names of the stars are given here. The Tamil names of the stars are given here. This is actually I got it wrong. This is the month and this is the star. Ashwini, Bharani, and you can see some pronunciation differences here because of the language. Ardra becomes Tiru Ardra and becomes Tiruvadire. Punarvamsu becomes Punarpusam. Aslesha becomes Ayilem and so on. The months are named after the star next to which Paurnami occurs. If Paurnami in a particular period happens next to the Ashwini Nakshatra, that month in Sanskrit is called Ashwina. If it happens next to Kritika, it's Kartika, Mrgasirsha, Margarisha, Pushya, Pausa, Magha. Very simple. And this is exactly what's happened in Tamil also, except the names have gotten much more character. So Ashwini becomes Aikasi, Kartika stays, Mrgasirsharam, no chance, becomes Margari, Magam is Masi. Pusham, this is very interesting. Pusam is a nakshatra that has two names, Pushya and Taishya. So the nakshatra retains the name Pushya, Pusam, but the month retains the name Taishya, sort of Tai. And all these stars also have scientific names and common names. Some of these stars don't have names in the Roman or other cultures. But now with science, of course, you have named almost every star in every constellation. So some of these are extremely bright stars. A thing to know is, we all know what the Earth's equator is. It's the halfway point, the rotation point of the equator is the central point of the spinning of the Earth. It spins around the axis, and the equator is the kind of the circumference of the largest radius, or the plane of the spin. But the plane of the spin of revolution or rotation is not the same as the plane of the revolution of the Earth around the Sun. We all know this. We know that we have learned that there is a tilt to the Earth's axis, 23.5 degrees. So this will probably work like this. So suppose this is the Earth, and normally it will spin like this. But what happens? Tilts and it spins like this. But when it goes around, pretend I am the Sun for a second, and it goes around my head, it does a clean sweep on an orbital plane. And the amazing thing about the solar system is all the major planets, the 4 inner planets and the 4 outer planets, up to Uranus and Neptune, all orbit in the same plane. And so does the Moon around the Earth. They all orbit in the same plane. It's not like Earth goes like this and Mars goes like this and Saturn goes like this. It's not like that. They're all in the same orbit. Only Pluto has an eccentric orbit. A lot of the comets have and asteroids have unusual orbits. But some of these have very mild tilts to the orbit. So instead of orbiting exactly like this, the Earth does, no problem. The Moon, what the Moon does, instead of orbiting like this, it goes slightly over like that and comes like this. And then it goes slightly over ahead and then it goes down like that. If it didn't do that, if the Moon didn't have this tilt in its orbit with respect to the Earth, if it didn't have that, every Paurnami would be a lunar eclipse and every Amavasya would be a solar eclipse. Because it does this tilt, it only coincides with the sun, the Earth and the Moon are in the same plane only during the eclipses. So most of the time, if you see the Paurnami, it's up here. You see the Amavasya is down there, it's completely dark, but doesn't hide the sun because it's not blocking the sun. That plane, the orbital plane, is called the ecliptic because it's only in that plane that the eclipse occurs. It's really the orbital. And it was called the ecliptic because they didn't know that for the most part, only one person in history and his follower, Aristarchus of Samos, a Greek, proposed that the world goes around the sun. There are a couple of Egyptians who proposed that the Mercury and Venus go around the sun. But only Aristarchus of Samos, the oldest source that we know of, proposed that planets go around the sun. He was rejected by Aristotle and then by Ptolemy, and only accepted by one person, Seleucus of Seleucia, which I talked about in my last lecture. And Seleucus of Seleucia said Aristarchus is right, the others are wrong. And of course, he was also rejected. In Indian history, there is some myth that Aryabhatta came up with the heliocentric theory. He did not. He came up with the rotation of the Earth, but not the heliocentric theory. Now here, the equator is shown from the east to the west right here. And this spherical, this line, that's the ecliptic. That's where, think of it as the orbital plane of the Earth, and think of it as the line that the Moon follows and most of the skies follow. That's the central axis of the rotation of the sky. So you can see that there are lots of constellations, formations of the constellations, formations of stars in different people. Different people look at different formations and call them constellations. They all name it differently. All cultures seem to recognize this particular one. Ursa Major has a lot of stars here. The Indians only saw 7 stars or 8 stars in Ursa Major. That is the Saptarishi. And there is something called, I don't know if there's one on the other side called Pleiades, that's Kritika. This is the constellations, these are the constellations we're used to. Cancer, Gemini, Taurus, Aries, Pisces and Aquarius. The other 6 constellations are obviously on the other side. We are seeing the night, the sun, the earth on one side of the sun. 6 months later, the earth will go that side. We'll see the other side of the universe, and the other 6 constellations will then appear. And you can see that all planets, and the sun seem to go through these constellations. In Indian mythology or Indian astronomy, what they did was they selected, instead of creating these patterns, looking at these patterns on the sky, they just selected some stars, the brightest stars. If this map is done in exactly the opposite fashion. Here, this curved line is the equator and the straight line is the ecliptic. It's the opposite representation. It's the same, mathematically the same, but the representation is different. That's for the one half of the year, and this is for the other half of the year. And I don't know if it's very clear, but this is Falguni here. This is Magha. This this is Pushya, this is Rohini, and so on. You can see this is Revati, and so on. And you can see that these are the stars that are the ecliptic, which has to be because they are named after where the moon was, or the stars that located the moon, the night sky, and very different. And this system was later abandoned by the Indians in terms of using, creating their astronomical text. I bored you with a lot of probably text and concepts, so I thought I'd show some pictures for a change. Those of you who attended my last lecture probably are familiar with this, but I thought we should look at the relative sizes of the inner planets. Earth, as you see, is fairly large. There's Venus, slightly smaller, almost the same size. Mars is much smaller. There's Mercury, and then Pluto, and our moon is roughly the size of Mercury. So imagine that. Our moon is very unusual. Earth's moon is very unusual. It's a solitary moon, which is not common. It is a very large moon in relation to the size of the mother planet. And it always turns the same phase. Its speed of revolution and speed of rotation are the same. So you always see the same side of the moon when you are on the Earth, or you see nothing. So very interesting. But if you think this is large, now that's Jupiter, Saturn, Uranus and Neptune, and the Earth has shrunk abominably, and Pluto has almost disappeared. Next we go to the Sun. The Sun is really 400 times the size of the Moon, nearly 100 times the size of the Earth. That's how huge it is. Fortunately or unfortunately, the Moon and the Sun share the ratio of their size to the distance. So the Sun is 400 times as far, but 400 times as large. So the side because of simple geometry, it's able to block the Sun at some point during the solar eclipses. And it doesn't always do that. If it tilts a little bit, or the orbit comes a little closer, because it's not a perfectly circular orbit, it's an elliptical orbit. If it does one of these things, then there goes it. And when it comes in the coincidental plane, when it comes in the ecliptic plane, but it has come a little closer, then you see the halo of the Sun around it. That's called the annular eclipse. Because the Moon at that point is somewhere closer to the Earth and it doesn't block it properly. Then we look at the Sun in comparison. We saw how small the Earth was, how small Jupiter was. We compare the Sun to some of the largest stars, and I have given the English names there and some of the Tamil names there. Sirius doesn't seem to have a Tamil name. Pollux is Punarpusam and Arcturus is Swati. Jupiter has almost disappeared. It's 1 pixel in this picture. And Earth is invisible at this scale. So that's how big this Arcturus is. And the Sun has come down to this size. And that's Arcturus, which is the largest star that you saw in the previous thing. That's sunk down to the size of a marble. There is Rigel and Aldebaran, which is Rohini, and Betelgeuse, which is Tiruvadirai, and Antares, which is Kete, and they're all eclipsing. Now the Sun has become 1 pixel, and Jupiter has become invisible. And if you look at the size of the universe, each one of these dots, each one of these things, is about 100 billion stars, 100 billion solar systems. And you think about that. And we didn't know about these kind of phenomena until about the 20th century, 1914 or so. When a man called Edward Schleifer started analyzing this, but he is not famous. Edwin Hubble he attended all Schleifer's lectures and became more famous. Which is fine, he was a major astronomer. And we didn't know about this. So before the telescope, even with the telescope, for 300 years, we didn't know truly what galaxies were. I'll make a lateral movement to Jain astronomy. The Jains had some of the things they shared with us, some of the cosmogonical perception of the universe is slightly different. The original text of the Jains are called the Purvas, they are said to be lost. Then the Svetamara said they recovered some of this from different oral traditions, and they compiled and classified the canons into Angas, 12 Angas, called Upangas, Prakirnakas, Jada Sutras, Mola Sutras, and Chulika Sutras. So all these texts are Ardhamagadi, they are not in Sanskrit. There is a Prakrit language. Some of these subsections, some of these individual texts which are part of these 12 Angas and all that, have mentions about astronomy. Among the Angas, 2 Angas, Stananga and Bhagavati Sutra have them. The Upanga, the Surya Prajnapati, the Chandra Prajnapati and the Jambudvipa Prajnapati have astronomical details. And the Surya Prajnapati is survived the test of time in terms of astronomical context. And It is spoken of along with the Surya Siddhanta and the Brahmasputra Siddhanta and Maja Siddhanta and well into later times. Then there are others. The Tandula Vaitalika talks about the lengths and time and so on. The Cheda Sutras don't have any astronomical text, they only have rules for convex and maximums. And then these two also have some minor astronomical information. So at the end of the Vedic period, you have the Ramayana and the Mahabharata, that's as we think of our culture, the Itihasa period. And somewhere in this period, the Siddhantas were compiled. There were 18 Siddhantas. Most of these are now lost. Only 5 remain. Only Surya Siddhanta remains or is still available in its proper full text, though there are supposed to be 2 different versions of the Surya Siddhanta. One was compiled, estimated to be compiled in 500 BC. The other is given as late a date as 1000 AD. I don't know what's true here. Of these, you can see that most of these are compiled. Surya Siddhanta is supposed to be, the story is that it's compiled by Surya himself. When Maya here is depicted as an Asura who wanted to know the science of astronomy, and he asked Surya, and Surya says, I'm too busy, I have to go around the world all the time, so you can't follow me, but go to, there is one recension which says, Surya commands Maya to go to a western city of Shudras called, Plechas called Romaka, learn from them, and this is, but this is not there in one Surya Siddhanta, this is there in another. So they are told that our Siddhantas came from Greece, which is not necessarily true, because 3 of these, the Siddhantas, the Lomasa, the Romaka Siddhanta, the Polish Siddhanta, and the Yavana Siddhanta, by their names you can see that they are foreign. Polish Siddhanta, these 3 survive, strangely enough. The Surya and the Pitamaha Siddhanta and the Vasishtha Siddhanta, I think, are the only ones that managed to survive the ravages of time. These 3 are clearly foreign, Greek and Roman. Paulisha is supposed, one version has it that it was written by a sage called Pulisha, Indian sage called Pulisha. The other by a Greek called Paulus Alexandrinus, Paul of Alexandria. Some people say he's only an astrologer, not an astronomer. But anyway, that is. And 5 Siddhanta, these 5 have survived. Surya, Pitamaha, Vasishtha, Romaka, and Palisa. I guess Yavana is also missing. These are referred to in Varahamihira as Panchasiddhantika. Surya Siddhanta is available. Varahamihira refers to all of this and says an astronomer, one of the qualifications for an astronomer is that he should know all of these things, all these 5 texts. The others were probably lost by obsolescence because they didn't have any extraordinary information that was not to be found in these. They are not necessarily burnt or neglected, or neglected in the sense that they became obsolete. They are not well written. And the highlight of the Siddhanta period is the adoption of the zodiac. And this is one reason why they suspect that the Indian astronomers borrowed heavily from the Greeks and the Romans. And recent information has revealed that the Greeks and the Romans have themselves heavily borrowed the zodiac from the Babylonians. So that's only discovered in the last 50-60 years or so. I'll go for a slight mathematical interlude here. Like I said, we are accustomed to certain ways of thinking because of how we are taught in the modern context. But reality played a different role. The Indian way of stating things was just statements, not formula. We say things like a plus b whole squared is a squared plus b squared goes to. I told you, algebra comes in the notation representation comes only in the 13th century or so. Before that, you didn't have algebraic notations. You had it as slokas, you had it as verses, you had it as statements and things like that. The other interesting thing is that the Indians use a different notation for sign, and I'll come to that. And the Indian sign was called the Jya. The Jya is a Sanskrit word for the half card, and I'll explain that a little later. The Jya was then adopted by the Arabs, and then they pronounced it as Jib or Jeb. The word Jeb in Arabic means pocket. Jebi, Jobi, we say that, means pocket. The Europeans were still using Latin at this time, borrowed it from the Arabs, and the Latin word for pocket is sinus. Nose is a pocket, it's a sinus. And so that's where we think, some people think the word sign comes from. I'm not entirely sure this is true, but it's a nice story to relate anyway. And we learn of sine as sine theta, sine 30, 45, 60, 90, and we say 0, 1 by 2, 1 by root 2, whatever it is on the formula. But that's not how the Indian texts talk about the signs. And then there are revolutions in Yuga versus orbital period. We learned also, I'll come to this, it's self-explanatory, and then there are corrections. My point is that Indian mathematical notation, we have to adjust our thinking to what they have said. Statement versus formula. I am going to do somewhat famous statement. One I knew, everybody knows, and one some of us knew of late. Pythagoras state famous theorem. The square of the hypotenuse is the sum of the square on the other two sides. That's a statement. We express it today as a mathematical formula. H squared is A squared plus B squared. But he didn't state it that way. He just gave a statement. He didn't come up with notations. And in Tamil, we have this saying by Kake Padiniyar, Vattattarai kondu Vittattarai taaka sattena thundrum kuli. Vattam is circle, Vattattarai is half a circle, half a circumference. Vittattarai is diameter, half of diameter is radius. Multiply half the circumference by half the radius, kuli is the area of circle. And we get the area. So, this is a very interesting feature of this is that this is a calculation without using pi. It's not in terms of pi times pi r squared. It's a very interesting formulation. Again, note that this is given as a statement, not as a formula. The formula notation almost only with 36. And all the Indian texts.
It's not r by 2 but r.
D by 2, sorry. That should be D by 2, not r by 2. That's radius. Circumference by 2 times diameter. Right. And this is the, interestingly enough, the man who is considered the father of algebra is Muhammad bin Musa al-Khwarizmi. We simply call him al-Khwarizmi. That's a town really. Khwarizmi is a town from which he is there. And his book is called Al-Jabr, and that's where the word algebra comes from. This is a section from his book. And you can see here is a statement. By means of a cube, the computation is take the square, remove the 1/3, remains 2/3, multiply the roots, find 2 cubes equal to 1 square, blah, blah, blah. There's a whole paragraph of this. That's the original logic into the English translation. Not a single equation, not a single variable, not a single square, not a single plus sign, minus sign, nothing. The father of algebra is using text. So this is what I am talking about. This is the modern notation. We probably learned this in the 3rd or the 4th standard. Orbital period of Mercury, Venus, Earth, Mars, Jupiter, Saturn, and so on. But how do our astronomical texts present this data? Like this. In the Yuga, which is 43 lakh 20,000 years, the revolutions of the sun are 43 lakh 20,000. So, of the moon, 5 lakh 77,000, 53,336. Of the Earth eastward, this. Of Saturn, 1 lakh 46,000. Of Jupiter, this. Of Mars, this. So they tell you a very long period, and they tell you how many revolutions the different planetary bodies of the stars take to do in this period. And that's how they state it. They don't give it in a nice little table. Probably because the notion of tabular notation was not there. You just put a series of numbers in a statement. And here, revolutions of the Earth, remember this is all geocentric theory. The revolution of the Earth really means rotation of the Earth on its axis, the number of days in that many years. And only Aryabhatta gives the number for the revolution of the Earth. All the others only give about the others hold that the Earth is stationary. And so you can see this is the modern tabular formulation of the numbers that they are given. And different people use different notations also. So Aryabhatta says this is millions rather than lakhs and crores, and so on. And this is from Policy Siddhanta, this is Brahmagupta's Siddhanta, this is Suri Siddhanta.
And why there are more zeros in Brahmagupta?
Brahmagupta rejects several things. Aryabhatta and we'll come to Aryabhatta's revolutions in source. We'll talk about it. The sign. You think of the sign as part of a triangle, opposite by hypotenuse is a sign. It doesn't matter how small or how large the triangle is, the ratio will always be the same, which is the foundation of trigonometry. The triangle will be the size of a molecule, it will be the size of the universe, no problems. But the Indian sign, I told you, comes from using what's called a car. I told you the word jya, of car. The sign here, think of this circle here, and think of this particular part. This looks like a bow, and the string that's used to tie the bow. So that's the car, right? And the Indian sign calculates it like this. The sign notations are given like this. That is the jya. The hypotenuse is the radius here on the circle. That is the jya. The cos is the not jya, and so on. The notation is effectively the same. Opposite by hypotenuse and cos will be adjacent by hypotenuse. But they think of it as in terms of the radius and give this and percentages of fractions of the radius. And this is hard to explain, but I will give you the numbers. Aryabhatta, for example, says that 24 signs. What 24 signs? The 24 signs are these numbers. That's not how we think of a signs. We think of sign, I told you, like fractions. 1 by 2, 1 by root 2, root 3 by 2, and so on and so forth. What he is really doing is dividing 90 degrees by 24. And he is giving the signs for those values. That's the 24. So if we divide 90 by 24, we will use notations of degrees. That's 3.75 degrees. That is 225 minutes of a degree. Got it? 60 degrees is a minute, 60 minutes is a degree. So 180 plus 45 is 3.75 degrees. And he uses a measure of the radius of the circle as 3438 minutes. And so, this sign, what it really means is 225 portions of the radius, which is 3438, 3438. You divide this by this, you get 0.06544. And sine of 3.75 is 06. That's the same thing. He's just giving it in a different notation.
And where does he pick this 3438 from? Just
that radius, that whole other Siddhanta right there. I'll skip that. And not everybody uses the 3438 division. They use a base, they use a number, and then they give divided by that. And this 24, there seems to have been some concept from Indian astronomers and mathematicians that a circle is divided maximally divisible into 96 parts. So when you divide the circle into 96 parts, the arc of the circle it becomes equal to the chord of the circle at the 96 part. So a circle, so if you take an iron ball like the basketball here, a fairly large thing. Now it's supposed, theoretically we think it's resting on a point. But they thought it is resting on 1/96 of its surface. 1/96 of its surface, and that part is flat. The mistake that they made is they didn't know about friction. What keeps it there is friction. You push it and it will start moving. So we know that Newton helps understand that. But so they divide the circle into 360 into 96 parts. The quarter of the circle for 90 degrees becomes 24 parts, and then so you have this particular notation. So this probably most of you didn't even know about, unless you're familiar with astronomy. We are all familiar with the Greenwich meridian, 0 degrees lat longitude. Equator, of course, doesn't belong to any country, but the Greenwich meridian comes as the British, the masters of science, discovered it. What most people don't know is that before the 0 meridian went to London, in Greenwich, it was 0 in Madras. The Anglican Orientalists who started the meridian system, Trigonometrical Survey of India started from Madras. They started the 0 meridian. The Madras was a 0 meridian. Rungamakam Observatory, I think, was a 0 meridian for some time. But that was simply unacceptable to London. So the 0 shifted to London. But this is only a British invention. The Indians have always thought of the 0 degree as the line passing from the North Pole to the South Pole via Ujjain. We are accustomed to thinking of Meru as the celestial mountain around which the sun disappears, the devas go, the stars go, and all this other stuff. The astronomers use Meru as the equivalent of the North Pole. For most astronomers, the North Pole was a very massive mountain, and their understanding was that the sun disappeared around the North Pole. That's why it disappeared. You couldn't see it. It went around the North Pole, or the Meru hid it, and then next day it came around, you could see it again. And the stars did it, and that was their conception. And so this Indian meridian is the meridian that goes from Meru, Ujjain, and Lanka. This Lanka is a general term for island. This Lanka is not Sri Lanka that we think of, but the Lanka directly on the equatorial position, directly south of Ujjain. If you take the longitude from the North Pole to the South Pole via Ujjain, where it will meet the sea? Right now that's just the middle of the sea, middle of the Indian Ocean, somewhere in the middle of the Indian Ocean. It's possible that there may have been some land there. But they also use 4 different points. They say there is these 4 different points: Lanka, Yamakoti, Siddhapura, and Ramaka. When it is sunrise at Lanka, it is noon at Yamakoti. So that's 6 hours to the east of Lanka. It is sunset at Siddhapura, so that is an antipode to Lanka. And it is midnight at Romaka, it's 6 hours behind us. And Romaka sometimes in the Romaka they use Yavanapura also. One or two astronomers use the word Yavanapura as Romaka. There are some Westerners and English commentators, Indian commentators also surmised that Romaka might be Rome and Yavanapura might be Alexandria. But neither of them is an equatorial town. So I don't know if that's true or not. I don't know if that's a correct estimate or not. And Aryabhatta uses Madhavamukha to represent the South Pole or the abode of the Rakshasas, abode of the Asuras, he says. And the South Pole is the home of the Asuras. The North Pole is the home of the Devas, Mount Meru. And each thinks that one is the other is beneath them. Because several people, including Aryabhatta and Varamira, realize that the earth is spherical. And they say, the Devas and the Asuras each think that the other is beneath them because they are on top of the world and the other is on the bottom. And they also mentioned, we are familiar with this thing that one day of the Devas, the gods, is 1 year. One year of the gods is one day of the gods is 1 year of the people. And so 6 months is night and 6 months is day. What our 6 months is one daytime for them, and what our other 6 months is one night for them, which is literally toward the poles. 6 months, we have 6 months of darkness and 6 months of light. And so I am wondering if this is also an allusion or an allegory with respect to the depiction of the Meru. And Indians also had this concept of the Kali Yuga. The belief is that the Kali Yuga starts with the end of the Mahabharata war, shortly after that. And at this period, the planets all lined up in one visible single line. And that's dated as the start of the Kali Yuga. So the Kali Yuga has an astronomical context, not just a treatise or what do you call it, spiritual or mythological definition. And this assumption is disputed with some Westerners. They made the calculation back. The date of the start of the Kali Yuga, by this estimate, is midnight on February 1718. The night when 17 ends and 18 starts, in 3102 BC. I told you already that most people, historians, will believe that the Vedas were only 1500, the Mahabharata is probably in 700. Those who believe that the Mahabharata happened say it's happened in 700, and that it was recorded, written only down in 700. And here we have this thing that says Kali Yuga started after the Mahabharata, and the date of the Mahabharata is 3102 BC. And an enormous number of astronomers, besides using the counts that we are familiar with, Masa, months and days and years and yugas and all these 60-year cycle and all other stuff, there is also a system in use called the Ahargana system. The Ahargana system is literally a count of the number of days, sunrises, from the start of the Kali Yuga. So every 1000 years we have 3,65,000 or 36,50,000 years. So the 1000th day from the 1000th year from that would be the 36,50,000th day from Kali Yuga. And the system kept on until somewhere in the middle period, and there are apparently some Chola inscriptions in Ahargana which I couldn't get in time for this presentation. I'll do it at some other point. And so this Ahargana system is also used. But some people say, and this controversy exists, there are several controversies in astronomy, especially I told you about the so-called Greek origins of the Surya Siddhanta. One of the controversies is that the Chola inscription, the Ahargana system and this particular date are retrospectively calculated to give mythological background to pretend that Indians are in great science, and that is not really true. So what's the point of all this? Why calculate 15 lakh days or 400,000 revolutions or 15 million revolutions or whatever? Why do all this astronomy? Why do all this 24 signs and 96 signs? Why divide all this? Why all this math? Why all this stuff? Why would you do this? What's the motivation? Rituals. Hindu mythology or Hindu system, we start from the Vedas, we do rituals. When do we do rituals? At specific times of the day, specific times of the month, specific times of the year, specific occasions of a person's life. Birth, a naming ceremony, a thread ceremony, a marriage, a 60th marriage, a death, annual this thing, your masya, you have Shraddhas, you have your Davasams, all kinds of rituals that you do. So, to mark this, to calculate the auspicious times, they use astronomy as a calendar system to calculate the right time to do the right things. One of the notations for a civil day or solar day was called the Samana day. It's called a Samana day as to distinguish it from the Nakshatra and the Tithi, sunrise to sunrise. The Samana is an offering that you make at morning, noon, and at sunrise, noon, and at sunset. And I wanted a more majestic one, so I borrowed from a hut that was supposed to be Rama doing the Ashwamedha. I thought I could get some good pictures of Yagna Yagashalas, but I think Google has so many, I could only get all the bad pictures come first, so I couldn't steal that also. And when you do a yaga, and not just these, a coronation of a king, when you start a war, all these are very strongly tied up with astrology, strongly tied up with rituals, strongly tied up with calculations, times and all that stuff. You know about how Duryodhana or the Kauravas went to Sahadeva to ask for when to start the Mahabharata war. You hear things about the Mahalya Amavasa, this, that, all kinds of things here. When to start building a temple and so on and so forth. The Indians squared a circle because if you ever look at astrology, they start with a square, and if you notice, there's 12 squares here, and these are the 12 represent the houses of these are the different signs of the zodiac, Mesha, Vrishabha, and all the things. But why not? I mean, it's not like we don't know how to use circles. Why conveniently divide it into squares? They have done this. And all horoscopes and jatakas and things like that are cast in the square mode. Why they did this, I don't know. And you can see this. And they observe this for any occasion. If you're born, something happens, they note this down. Now we have paper, but for the most part they use Bhojpatra or palm leaves or something like that. And individual people would generally not necessarily have their own jatakas or any of their horoscopes or anything. The Jyotir, the astronomer or the astrologer of the family will have that. He will cast things of famous people will have that, and he will compare and do all these things. So very interesting. Even today, you will see people will start drawing chalk lines on the ground and the astrologer can start with chalk lines and start calculating. Very interesting. And these people have kept most of our. So we generally mock astrologers. The scientific community mocks astrology, and I personally don't believe in astrology myself. But astrology and religion has what kept all these texts alive. All our science, a lot of our science is lost because those texts have not survived. But astrology and astronomy are so intricately linked that all the scientific texts, the mathematics, everything, it's invaluable, it's indispensable. So all those are survived. So religion has made a great contribution, and astrology has made a great contribution in preserving our history. And let me illustrate this. You have seen this. I have censored out the names. And the person is not here, so neither of them is here. So you've seen this kind of invitation. I'm only using a subset. There's all kinds of other things like Muhurta and all other stuff. So you have all this. Now let me give you an illustration of where all this comes from. So the Tithi, the Nakshatra, and the month Aipasi are Vedic, are Vedanta. The month October. October is the 8th month. Akta, Sapta, Octo, Nava, Dasa, 8, 7, 8, 9, 10. That's the old Roman calendar starting in March. So we retain the name of the 8th month for the 10th month. But this thing it's Gregorian. It's Julian adaptation, then Gregorian. It's Christian really, with the Gregorian modification. The day of the week is of Sumerian origin. The division of days into 7 days of the week is of Sumerian origin, and I discussed this in my last lecture about astronomy, ancient cultures, which then the Greeks adopted. Vyadakkadamai in English is Thursday, Thor's day, and Wednesday is Odin's day. Odin and Thor are gods of the Vikings. That religion is gone, but the names still remain with us. So the 7 days of the week, people thought they come from Greece or Romans, but they actually come from Sumeria, and they have non-Roman, non-Greek, pre-Roman, pre-Greek European names in English. So, and then we have the time of the day, 10 o'clock. The 12-hour and the 24-hour notation is of Egyptian origin, and I discussed this also in my last lecture. I'm not going to talk about it in detail. Whereas the minutes and the seconds are of Babylonian origin. This is post-Sumerian. And you can see why I avoided the muhurtas and all the other stuff. This is getting crowded already. And finally, the Vikruti, the 60-year cycle might have come from the later period, the Siddhanta period. This, some people believe, is the cycle of Jupiter. Jupiter takes 12 years to go around. And you had the old Yuga system of 5 years. And 12 times 5 is 60, and there are some, you will see some combination of the other of mathematics, astronomy, and some other thing will come. It's a pretty corroded notation. So when you get a invitation for a wedding, you get a truly global. Only thing missing here is Chinese and Russian and probably the Maya calendar. So now we come to the. I am way behind. I am about 35 minutes behind. I have 10 minutes left. Now we come to the Aryabhatta phenomenon. This is a monument in, I think, some museum there in Bihar, I think. And this is a depiction. Pune.
Institute of Astronomy and Astrophysics.
Well, first of all, Aryabhatta, this is depicted as a Brahmin, I think. It's supposed to be a Brahmin, but it's not a Brahmin. And I'll come to this. Aryabhatta was one of the most brilliant scientists India has produced. He is the Newton class, and some people call him the Newton of India, even though Newton came 1,000 years after Aryabhatta. It should be called probably the Aryabhatta of England. But such is, I mean, you can call Samudra the Napoleon of India. You can call Aryabhatta the Newton. And he's a scientist in a class apart. Darwin, Archimedes, Algorithm, you go into other fields, Kamban, Mani, he's in that class. Aryabhatta stands alone. And it's Aryabhatta, not Bhatta. Bhatta would be a priest, a Brahmin priest. Bhatta is a soldier, probably a Kshatriya. He was the first Indian astronomer not to be considered divinely inspired. We saw the authors of the Siddhantas, except the Yavana Siddhanta and other stuff. Everybody else is all the Maharishis. They were all taught by the sun or Brahma or Vashishta. They are all divine influence of this thing. Aryabhatta has no such pretensions, and he is not. And he is considered by even Indian scientific community today as the founder of scientific Indian astronomy. He seemed to have lived in Kusumapura, which is identified as Pataliputra. There are one or two people who dispute this, but I think the identification is correct. And he is also thought by some to have been the Kulapa, that is the chief of the scholars at Nalanda. Whether this is true or not, I don't know. His major work, called the Aryabhatiyam, or the Arya Ashtasatas, I'll come to that later. The Aryabhatiyam, and this is one more reason why if his name was Aryabhatta, that would be Aryabhatiyam. It's only Aryabhatiyam, and though for 1,000 years they referred to him as Aryabhatta and Aryabhatiyam, not Bhatta, Bhatiyam. And this has 4 chapters: the Dasagitika, the Ganitapada, the Kalakriya, the Gola, and their translations to be 10 poems, mathematics, the reckoning of time, and the Gola here is the celestial sphere, the sky. A later astronomer called Suryadeva Yajman, who lived in Gangaikonda Solapuram and was astronomer for the Chola Empire, believed that these are actually 2 different texts. That the Dasagitaka is one text, and the other 3 are in one second. The other 3 is the one that's called the Arya Ashtasatas, because they are 108 in number. Because he says there is an introductory poem and a concluding poem to this section, and an introductory poem only in the Ganitapada and a concluding poem in the Gola. So they probably are 2 different texts. So apparently it's good. Suryadeva has written commentaries on several different things. We come to Suryadeva. The Dasagitika lists astronomical constant. I showed you the earlier text where they talked about the 24 signs, the orbit, the revolutionary periods of the different celestial bodies and so on. And the Dasagitika lists all constant, like then it talks about other kinds of constants which even more complex astronomical numbers I don't want to go into. These are written in what's called the Arya meter, like the Mandakranta meter or the Gayatri meter. It's a different chandas. And that's why it's called the Arya Ashtasatra, that is known as 8 plus 100. And in one of the slokas, he says, Aryabhatta says, and this is a translation, when 3 Yugapadas, and this is the 3 Yugas that he's talking about, Krita, Treta Yuga and Dwapara Yuga have gone, and 60 times 60 years, 3600 years have passed, then 23 years of my life has passed. So what he's saying is 3600 years from the start of Kali Yuga, I was 23 years old. That is the statement. And from there, so look at what a complex, it's a slightly complex statement. From there we guess that he was born in 476 AD, because if you accept the 3102, 3600 is 499, and you get from there. Suryadeva Yajvan's explanation for this data, he said, why would Aryabhatta include his date of birth? Because we don't, this controversy that we have, whether Kali Yuga really was 3102 BC. If we accept this dating, Aryabhatta believed that Kali Yuga was there. But we don't have any astronomical text that says, on this date, the start of Kali Yuga, these moons, this star, this planet, this thing was here. We don't have any surviving text. Aryabhatta says, I was born now, I made these observations, this is my date I am giving with reference to that date, so now you know what the calendar is, and here are the constants I am giving. Now you have zeros. Now you have initial points from Aryabhatta's date. And if some of those calculations are wrong, you are confused, you can go back to Aryabhatta. The starting point is there, and his date is clearly given, which here it is. So Suryadeva's Yajvan's logic is this is the 0 point for Aryabhatta's constants. And then you can add or subtract from that using all the formulae and the mathematics and the other things. And this is a very interesting passage. In one more sloka, he says the first half of a yuga, this is Aryabhatta, is Utsarpini, second half is Avasarpini, the middle of a yuga is Sushama, and the beginning and the end are called Dushama. Suryadeva says this statement above requires deep contemplation to understand, because he doesn't know what this division is. And finally he says, I don't understand. I think a lot of us can share a lot with Suryadeva Yajvan. We find it really difficult to understand a lot of these concepts. And look at the honesty of this fellow. He says, I don't understand. He is the chief astronomer of the Cholas. He is a major astronomer himself. He has written 6 commentaries that survive today. He was in communication with Parameshwara, who was an astronomer in Kerala at that time. This is Aryabhata's scientific propositions that are novelties. One is the rotation of the earth. He is the first person to say that the earth rotates. If you stand on Lanka at the equator, you sit on a boat in the middle of the sea, just as if you go on a river, the trees on the banks seem to go past you when you are going forward. If you sit there, the stars will look like they are moving backward. The sky looks like it's moving backward. No, earth is rotating. So that's why it's moving backward. Great revolutionary. First proposal. Second, he said Meru was not a mountain, even if it is, it's not very tall. Meru is simply the North Pole, and it should be simply taken as the pole. I'm not worried about all this devas, all this complexities about 8,000 yojas, 80,000 yojas, and how big it is. He redefined the yugas. I'll come to the yugas a little later. He gave different numbers. The Indian yuga system has the Treta Yuga, Dwapara Yuga, Treta Yuga, Dwapara Yuga, and Kali Yuga. These are all different periods. And then there's a thing called a Kalpa, and then there's a day of Brahma, night of Brahma, Mahayuga, all kinds of complex things. And he says no, he divides the Mahayuga into 4 yugas, all of equal times. And I can see how the community reacted. He's first saying the earth rotates, second he's saying there's no Meru, third he's saying I'm redefining the yugas. Then he says midnight at Lanka is the start of the day. This is not defined in the Aryabhatiya, but in a different book called Aryabhata Siddhanta. It's a follow-up book. And he says midnight, day should start at midnight at Lanka, not at sunrise at Lanka. Then says, he starts I made a spelling mistake there, that should be new numeral system, not new number system. Use the decimal number system. But he uses a different connotation he uses his own connotation for the decimal number system. And this is not followed by anyone. And these 5 revolutions are enough to get him criticism, not in just his own time. For the next 1,200 years, Hindu astronomers keep criticizing. Everybody says, how could Aryabhatta say this? And his most virulent critic is Brahmagupta. He says, this fellow is not an astronomer. Completely dismisses Aryabhatta. This fellow is not an astronomer. He doesn't know anything. Not only is he refuting Smriti, he is talking complete nonsense. So, and finally, he inspired the Aryabhatiya school of astronomy. The fact that society in general rejected him doesn't mean everybody rejected him. Like the Vedas and their plurality, we have astronomers and their plurality. And there is a long school of astronomers in Kerala which followed this Aryabhatiya school. They made major contributions to algebra and trigonometry. The rotation was criticized by everybody. All these people, different times when they're giving you this thing. Brahmaguda's reputation was, the refutation of all these people was criticized by Al-Biruni when he came to India in the last century and said, Aryabhatta was right, you guys are all wrong. And I move on to the instruments. These are, unfortunately, I'm really handicapped because there are not too many pictures of Indian instruments from that time. These are normally researchers from different parts of the world. This is European, I think this is Chinese and so on. There is another device called the astrolabe, which I also talked about in the previous lecture. The Indian instruments, there are very simple instructions for building these things and are very, how should I put it, very detailed or very, the instructions are simple and the materials that are used for construction are also very simple. This is Surya Siddhanta, it says Paradara, Ambu, Sutrani and all that stuff. So these are what it's talking about. Ambu is water, Sutrani is thread and so on and so forth. And you can use this and you can make astronomical instruments. And Lalla in his book says these are the famous 12 instruments that he lists: the Goda, the Bagana, Chakra, Dhanu, Gati, and the words translated are sphere, ring, dial, bow, all that stuff. Does any of this look like an astronomical instrument to you? But they were used that way. They are geometrical instruments, astronomical instruments. And they use this, obviously, this is the models I am giving. This is the Yasti Yantra of Bhaskara. This is, of course, a very modern construction of the Yasti Yantra based on Bhaskara's description of how it should be built. It's a very simple trigonometric principle. You take this device, you set it on the flat surface with some other object that you want to measure the height and the length of. Then you put this pivot focus here. Now you have these two triangles theoretically. And based on this basic simple trigonometry, you use this. This triangle, upper triangle is congruent to this triangle. The lower triangle is congruent to this triangle. And this lower triangle's height we get from this simple formula and you calculate this. You can calculate the length and the height of any standing thing. Theoretically, you can calculate even astronomical things, but there are other aspects of that. So, very simple device. And all instructions for constructing astronomical devices are like this. But nothing seems to survive. I mean, simple things like a water clock or a clock that follows something. He says, devise a metal sphere, oil it well, put a metal rod through, hang a pot of water on it, put some water in it and make a scroll that the water drips slowly. Put an axis in the center so that it aligns with the star. And make sure that it aligns, you oil it and align it so that it moves with the star. You have a clock in respect to the star. It's easy to say, easy to follow, whether you want to build a clock like that. And this is one more water clock of Bhaskara. That's the schematic. And somebody has actually built it, like, got a copy of this from one of these books here.
There are two Bhaskaras. So which?
I'll come to that.
Which Bhaskara is this?
I think this is the second one. Moving away from Aryabhatta, we'll go to Varamika. I'm going to pay disservice to a lot of these things. I'm 25 minutes to show you. Varamika was an astronomer who was born in Ujjain. His Mihira probably comes from the sun-worshipping cult in Kalinga. His parents came from Kalinga. He wrote three major astronomical works: Manchittantika, which is really astronomy, Brihad Samhita, and Brihad Charaka on astrology. He asks very interesting questions. He says, if Brahma says Tuesdays are auspicious for this, and a man says Tuesdays are auspicious for this and that, what's the difference between a God and a man? Two people can, God can say something, a man can say something. What's the big difference? Very interesting. But he also follows, unlike Aryabhatta, he doesn't refute a lot of this theory. He says if Rahu's motion is not fixed by laws, how is it that we can calculate it? We can calculate an eclipse. But you are saying Rahu is a celestial being who goes eats the sun and the moon. That can't be true. And he says the shadows of the moon and the earth called eclipses. It's a disk. The shadow on the moon you can see starts as a part of an arc and then moves. The shadow of the solar eclipse always starts in this direction, and the lunar eclipse always this direction. So you understand that it's periodic, it's not arbitrary. If Rahu is covering this and he has a tail and he can eat the sun, why is he not eating other stuff when he is not eating the sun? Why is that not being blocked? This is all kinds of stuff. So questions like that. He looks at the cosmology, and I think I skipped this. He talks about the qualification of the Jolika. I didn't look at the Panchasiddhantika, but I looked at the Brihad Samhita. Even though it's astrological work, there are a lot of astronomical information there. He talks about the qualifications of the Jyotishaka, an astrologer. He must be of noble birth, agreeable appearance, meek, truthful, without jealousy, proportional limbs, joints, well built, good growth, no physical defect. Where is he going to find these people? I don't know. And then he goes on, and the virtues, clean habits, noble mind, eloquent, originality, imagination, hygiene, accomplished, must be a worshipper of the Devas, observer of facts and plans, blah, blah, blah. There's a good reason why this is called the Bharat Samhita. He must know, that's the personal qualities and the virtues. Know what he must know. Solar and other divisions of time, the divisions of other things, man's, prithvi, sidereal, methods of calculation, astronomical works, shadow and water level, the means of shadow and water level, help of astronomical instruments, the termination of the ayana, reason for the correction required for the conversion of heliocentric. This I think is interesting. There's no heliocentric here. This is probably a sprint of something. The Puranic Yuga, as I told you, is the Kali Yuga, 4,32,000 years. The Dwapara Yuga is twice the Kali, the Treta Yuga is 3 times the Kali, and the Krita Yuga is 4 times the Kali. So one Yuga or Mahayuga or Chatur-Yuga is 10 times this. 1 plus 2 plus 3 plus 4 is 10 times this. So it will be 43,20,000 years. No other culture even has numbers coming close to this. And this Yugas, one Yugas, I see different notations. Each thing comes differently. One is called a Kalpa, day, one Yuga is a day, the other Yuga is a night. And 100 days and nights is a Kalpa, and 100 years is a day of Brahma, 100 nights, 100 years is a night of... The numbers go into somewhere in the billions and the trillions of years at that point. Aryabhatta redefined this. He defines each Yuga into equal sections, not in these unequal sections. And that's one more reason why he was rejected. So divisions of time mentioned by Varahamihira. So that you have Yuga, of course, and then the particular Kali Yuga. The Varsha, the solar year, the Ayana, this is the Uttarayana and the Dakshinayana, 6 months of upward, downward movement. The Ritu is the 2 solar months, that's the 6 seasons. The Masa, the Paksha is the things of Krishna Paksha. Ahoratra, the Yama, 1/8 of a solar day. The Muhurta is 1/30th of a solar day, that's really the hour of the Indian calendar. And Nadi is 1/60th of a solar day, that's half an hour, it's 24 minutes. But this 24 minutes is ours, what we understand as minutes today. But this is half a Muhurta. The Vinadi is 160. You can clearly see the influence of the Babylonian sexagesimal system here, basic C system. Our Prana is 4 seconds. And there is even a definition going downwards into the Dhruti. They can't even calculate a second. Where do they come up with 1 by 33,758 of a second? So, all divisions. Go into extremely tiny measurements on this side and extremely large measurements on the other side. Astronomical. So, this is other divisions of time. Manusmriti, here, what is a nimisha? 15 twinklings of each blink of an eye is a nimisha. You twinkle 15 times, you get a kashta. 30 kashtas is a kala. 30 kalas is a muhurta. 30 muhurtas is a day. That's one definition. 10 long syllables. Not twinkling of an eye, how we pronunciation. 1 respiration or a prana. 6 respirations is a vinadi. 60 vinadis is a nadi. 60 nadis is a day. Each text defines its own number system. Each text defines its own system of units. Each text starts defining. How do you keep track of this? I just gave you a small example here. The 6 seasons, if you want to know, are Vasanta, Grishma, Varsha, Sarad, Hemanta, Shishira. Not the 4 seasons that we are familiar with from the European notation. And then there's also Tamil equivalents for that, but I think I might have got the order mixed up. I think they are right, I'm not sure. Varsha here really means the 2 rainy months, it's the season, not the year. Then Brihat Samkhya started. You saw the 4 chapters of the Aryabhatiya. One was the constants, one was mathematics, one was time, and one was Golas, sphere. So here is astronomical stuff. The Jyotishkas, the qualification that we just saw, chapters of the sun, moon, Rahu, Mars, comets, Agastya, Saptarshi, constellations, rain, dust, Indradvaja, lustration, clouds. Then we see more chapters on temples, umbrellas, on the features of cows, dog, goat, horse, on the price of commodities, on amiability, the 5 Mahapurushas, perfume mixture, constellations, Tithis and Karnas, entry into the forest, durable cement. What does this have to do with astronomy and astrology? And it goes on, gardening, diamonds, rubies, emeralds, lamps, carts, seats, toothbrush, pimples. I think he's captured the essence of my presentation also. I'm also talking about the brilliant presentation, you know. So, he also talks about 10 different kinds of eclipses. Astronomical information, Savya, Apasavya, Lehana, these are words in brackets are translations. A solar dimming, not a proper eclipse but a dimming of the sun. Grashana. And it talks about what consequences are, floods and joy if this kind of eclipse. Tyranny and robbery. Rich princes will suffer. What happens to the poor princess? Nirodha, blocking, Avamardana, dormant, total and long, a very long eclipse. Arohana, climbing. This is a very rare eclipse where the solar eclipse is followed by an eclipse by a meteor or an asteroid. Have you ever anybody heard of this kind of thing? And he has a term for it. Not only does he have a term for it, he also tells you it is rare and it gives you a whole bunch of consequences. Vaishyas will have, this thing will happen to the Vaishyas, this thing will happen to the charioteers. Brahmanas will prosper, ladies, all kinds of stuff. Then smelling, a very faint kind of eclipse. Like the sun, where the sun is covered like being a mirror misted by air or a hot breath. That kind of eclipse. Madhyatama, this we can understand, that's an annular eclipse, centrally dark. Antyatama, centrally grey and dark around the edge.
It's not.
What is that possible even?
Not possible.
And these are the other predictions that he makes. If the solar and lunar eclipse falls between the lunar month of Kartika, persons will be by fire, the Magadhas, the eastern princes, the Koshalas, what do all these people have in common? They will all suffer miseries. The ruler of Kalinga with his ministers and servants and the Kshatriyas will perish, but there will be prosperity and plenty in the land. The eclipse should fall in Margashisha, Kashmir, Oud, Udra will suppress, waterpools will perish, men of the western countries will suffer. This is 69, 70, 71, 72. He just goes on and on and on and on. There's a good reason it's called the Brihad Samhita. And I'm going on and on and on too. So this earns some criticism. You look at the Panchasiddharthika. It is very deep thoughts. This is like a little like Newton. Newton wrote a whole bunch of things about alchemy, how to convert metal into gold and all kinds of other stuff. We don't know, most of us don't know this aspect of Newton. He tried to do the philosopher's stone. He tried to come up with a stone for the immortality of life to transmute a stone that will touch and transmute metals into gold. And he did this after coming up with the optics, after coming up with the theory of gravitation and the theory of motion, went off on the side track. And Paramihira seems to do this, and Al-Biruni criticized him and said, why does Paramihira do all this? What is he trying to do? Why is Paramihira indulging himself with this kind of stuff? But that still survives. People believe, astrologers will tell you all kinds of things from those things. And the later astronomers, and I am giving 1.5 hours and I talk about 2 astronomers. And I am still in the 7th century here. And then the other great astronomer, the Refutation, who wrote a book called the Brahmasputa Siddhanta. My point was simply to give you the flavor. You know that this is completely a vast topic, I can't cover it. Even what I have covered, half of the stuff, you won't remember, a bit of it, I won't remember. But you get a flavor of it and you know, oh, at least this is there. That's what I'm trying. Then there are 2 Bhaskaras, one Bhaskara in the 7th century and a second Bhaskara in the 12th century, just like there was a second Aryabhata. The first Bhaskara wrote 3 books, Mahabhaskariya, Laghu Bhaskariya, and he wrote the Bhashya, a commentary on the Aryabhata, original Aryabhata's book. The second Bhaskara is the mathematician that you are very familiar with, wrote the Siddhanta Shiromani, the Bijaganita, Lilavati that you are all familiar, probably familiar with. There is an astronomer and an instrument maker called Madhava of Sangamagrama. Sangamagrama is a translation of Kudalur. Kudalur is not Madurai here. It is a village in Kerala, supposedly on the banks of the Bharatpura river. Also called the river. He is called Godavida, the genius of in making the artillery spheres, the Godas. There is another called Sripati, Parameshwara, Nilakanta Somayaji, Jeshta Deva wrote the Iktibhasha. Parameshwara came up with a system called the Trikanita, which I talk about. Tantra Sangraha and Jyoti Mimansa are the 2 great contributions of Nilakanta, and I am not going to talk about those. I am just going to go with I also want to talk about the geographical variety, the different places that these astronomers belong to. Aryabhata and Pataliputra, Arakira from Ujjain, Brahmagupta, Punjab, probably Multan, Surya Deva Yajvan, who wrote commentaries from Gangai to the Swarnapuram, the Chola territory, Parameshwara. Kerala, of course, has a very long history of this thing. A very important, skipping Brahmagupta and Bhaskaracharya and Madhava because I'm coming to Parameshwara. By this time, Parameshwara is in the 13th century, I think. I got that date. And by this time, just like Aryabhatta corrects the mistakes of the Surya Siddhanta, because what happens is all the observations are made in geocentric theories with some errors and time. Everybody, all astronomers know that errors will accumulate over time and they have to correct it. So Parameshwara, using Aryabhatta's calculations, 800 years have passed, he is using it. They don't know that its calculations are wrong because it's using heliocentric theory. They know the calculations are wrong, so he starts correcting them. And how does he correct them? Actually, in Kerala, there is a person called Haridatta who came up with the Parahita system which corrected the predictions of the Surya Siddhanta in the 7th century itself. So, in the 13th century or so, Parameshwara comes up with something called the Drik Ganita. And he says, Drik is literally looking. Ganita is calculation. Look and calculate. He says, don't blindly trust the books. When one's calculations disagree with planetary positions, one must adjust the calculations. Because the planets won't adjust their parts just so as they'll agree with your calculations. And this is advice for us when we try to understand astronomical texts. So they make statements rather than give tables or formula, we have to understand them. Brahmagupta will not rewrite his theories in algebraic formulas. Aryabhatta will not. They will not give us tables. We have to reformulate. And so Nilakanta Somayaji, who comes shortly after Parameshwara, he says, this is in Malayalam, I am writing in the Tamil script. Sirakaram Karinyapur Nikam Balare Vanditu. After some time, the distortions became bigger. And follow some of it, right? It sounds like Tamil. Ranga Shobhanu Kalyabde, and Ranga Shobhanu is the year 4532 of the Kali Yuga. I told you, Aryabhatta said 3600 of the Kali Yuga. This is 4532 of the Kali Yuga. This is 1431. And this is a system called the Karatayagi system, and it's used at Raga Shobhanu, Ranga Shobhanu Kalyabde. Still there are some problems. Paschimambodhi Tirattu Nimnu Nokittu Vachadu. Paschimambodhi is Western scholar. Tirattu Nimnu Nokittu Vachadu. He made a collection by Drik Ganita. Nimnu Nokittu. Paschimambodhi is the scholar of the Western seas. In this case, Parameshwara. And he is complimenting him. And Nilakanta himself comes up with corrections to Parameshwara's observations. And then I will go to the Guru Parampara. In Kerala, we have, and in most places, we have a Guru Parampara, where the knowledge passes from Shishya to Guru to Shishya, from Shishya becomes the next Guru, and so on and so forth. And not just in the arts, but also in the sciences. We have the mention of Govinda Bhattagiri being an astronomer in this period, who taught the father of Parameshwara. The Parameshwara that I told you is the author of the Drik Ganita. So his grandfather, Parameshwara's grandfather learned from Govinda Bhattacharya. Then Damodara learned from Parameshwara, and this Damodara is the son of Parameshwara. Nilakanta Somayaji learns from Damodara, Jeshtadeva learns from Nilakanta, Achyuta learns from Jeshtadeva, and so on and so forth, all the way. And the names are also very interesting. Pulimugattu Potti, Mangalari Dakshinamurti Musaddu, Nalekatti Balaraman Pillai, and this is Prince Rajaraja Rama, and this is the Prince of Travancore. And this comes all the way from the 13th century up to the 19th century. So we have Guru Parampara Shishya. We don't have documents for the Guru Parampara Shishya for some of the other cultures, but they may also have a long this thing. I think I should stop with this. I think we are way over time. I think we'll stop with that. We'll stop with the 15th century. Dragged it a little bit to the 18th century. The others are some explanations from the previous thing to understand some passages. I don't know if I have a concluding remark. My point simply was to expose you to how much there was, to expose you to a different system of thinking, expose you to a different system of data, information, debate, process, and all that stuff. And to understand that science is part of our culture, astronomy is a major way of representing science. And I represent a very small fraction of what this is. Not very visual, very conceptual, very somewhat mathematically heavy, and text-heavy presentation. But I hope you got something out of it. Thank you very much. Gopu questions, yes, please.
You have the cyclic completion of the zodiac, and then comes the forecasting of the astrology has not laid down anything for palmistry.
Astronomy what?
mic எடுத்துக்கோங்க. Gopi.
I don't know about palmistry. This is only related to the stars.
Go, mic.
Whether I don't know this, the astrology of the Jyotisha is the lagnas and the planets and all that stuff. That's clearly celestial literature, astronomical from stars and planets and astronomical data. That astrology. Palmistry and Nadijosium and putting this story and all that. I don't know what the origins are. I know, I told you, I'm not an astrologer. I don't know anything about. If you ask me any question about astrology, I really don't know. I can tell you that astrology inspired astronomy and vice versa. They took a lot from each other. The modern astronomers, if anything, they have now included Uranus and Neptune in a lot of these horoscopes. They say, you come up with something, we'll add it. And when Pluto was demoted, astronomers didn't care, but astrologers cared a lot because they said, if the scholars, even if you are Western scholars, if you are saying this is not a planet, then it affects our calculations. And so, that's also good.
You mentioned some names. It's a fascinating talk. You mentioned about some names about Punarpusam and some star, nakshatrams, and relating them to some planets or something, stars. Stars.
Yeah.
So, how can you explain that?
Sure.
What is the
Betelgeuse.
same name? Refers to both, or only some nakshatras are known like that? Or?
We can see 6,000 stars in the sky without naked eye. Okay? The 27th, and so the moon goes around. And moon goes around, there will be lots of stars on the path of the moon. Let's say there are about 50-60 stars on the moon. We have selected 27 stars. The Hindus have selected 27 stars and given them names. For example, the Saptarishi also have names. But the Saptarishi is not part of these 27 stars. That's a little further on. It's not on the path of the moon. So the Saptarishis have names like Vashishta and Marichi and Ratri and all that stuff. So these 27 stars have names. But the 27 stars are not, the names are not confined to us. Other people, the Westerners can give them their own names. That's what they have given. So, Arcturus or Antares is called Ketai by the Westerners and so on and so forth. Each star is given a different name. I showed you, you're asking related to the pictures I showed and of the stars and all that stuff, right? You want me to go back to that? I can show you. That's just naming convention, that's all. So, Sirius, Pollux, Arcturus, right? These are the names the Westerners have given. I don't know what the Sirius has a Tamil or a Sanskrit name. But the star that the Westerners called Pollux is called Punarpusam by us. The star that the Westerners called Arcturus is called Swati by us. The same star. And in today's astronomical calculations, we have calculated the size of the stars is this big with respect to the sun, or in absolute terms. And ditto for all these. Rigel I have just given because I don't think Rigel has a name. And Aldebaran, Betelgeuse and Antares are called Rohini, Thiruvadre and Ketai. The other stars also, because if Aldebaran is the same size as say some other nakshatra, I have given it here. I only mentioned some nakshatra. This is the map I got of the internet. So I'm showing you the selected stars.
One more observation is that you mentioned the name Jia, being a student, professor of music. The name Jia is also related to yard. It was interesting to see the diagrams you gave, and while constructing the yard also they have used that circle and the lines.
One point I thought I would make and I didn't was that different sections of people had different mathematical interests also. What a merchant did with math and the account should be different. And what merchants do not necessarily know all these things. They use their math, and astronomers do not know what the measures the merchants use. So they have their own different words, they have their own different points and calculations.
Group Parampara stopped at 1846 in the child. When did it finish? So what happened after that?
I have no idea.
Why did the Danes have astronomy and they don't believe in rituals?
question asks, why do Jains have astronomy when they don't believe in rituals?
They have their own rituals.
They do have rituals.
They have a lot of rituals.
They don't have just a little bit of astronomy. They have tons and tons of astronomy. Even in the Hindu system, there are people who don't believe in rituals, who don't follow. They have pluralities. Jains also have a Satambara and a Digambara culture. Different belief systems coexist. Both in Hindu system and in the Jain system, in Buddhist, for example, there is one set of Buddhists who criticize astronomers as bad people, misleading. One set of Jains have criticized them. One set of Hindus have also said these astronomers are very bad for us, not associated. That's also there. Common opinion is there. Others said we consult them for everything. The famous Kautilya in Arthashastra says, he has the whole scientific process. He talks about it. I didn't include that because already I am way over time. Kautilya says, what is tremendous stars? What do you believe that, what on earth do you think has anything to do with your life? There are some things far away. Your life is there. Why do you believe in this nonsense? So he criticizes that also. But he's not the only one. Others also do that. Even astronomers criticize each other's beliefs. As you saw, I showed some examples. And I could barely cover anything. I think if you saw Varaha Mihira's predictions were entertaining. You should see Brahmagupta's comments on Aryabhatta and then Al-Biruni's reputations of Brahmagupta, thoroughly entertaining. So,
I just want to make an observation. I think the so-called neo-astronomers are today's ministers. You know, they're astronomical figures. I don't think any of these touch.
I think there are plenty of controversies in astronomy without bringing politics into it. Okay, now comes the kicker, all the mistakes I make.
I have a doubt on bikes on that. Is there any reason for 7-day week? I read some once there was a 4-day week also, but now the 7-day week is all over the world. If I say this Nakshatram is Aslesha, I know the meaning. Moon is by the side of this Nakshatra. If we say this month is Chitrai, I know Sun is in Mesha Rasi. If we say this is Saptami today, Moon is in its 7th place. But today is Saturday. What is the reason for Saturday? Why this day is called Saturday? Why this day is called Saptami? I know the reason. Why is this Chitrai? I know. Why this Nakshatram is something? I know. But why this day is called Wednesday? Why this day is called Sunday? Is it following cycle? What is a 7-day cycle? Is there an astronomical basis for this 7-day cycle?
I talked about it the last time. I don't know if the slide is there. I have to go over the other presentation. I talked about the Sumerian people. They followed the cycle of the moon, and they had a celebration for the half percent, the full moon, and the second half percent. And again, when the Amavasya you can't see the moon, but also on the next day you can't really see the moon. And they looked at this 29-day cycle, and they are missing 2 days of seeing the moon. They had divided this lunar period into 4 periods of celebration, and they skipped that sequence. They calculated for the Amavasya, but skipped those 3 days or 2 days in the middle, and they can't properly see the moon. So, for Saptami or Ashtami they had some festival, and on Paurami they had a festival. In the next Saptami or Ashtami they had a festival, and then on the assumption that there will be something they had a festival, and they dropped or confused in the festival. Somewhere in that confusion, so this 4 split of the 29-day cycle, 29.5-day cycle. Later, and they skipped the middle day. You have the Egyptian calendar. Even though it was a 365-day year, they used 12 months of 30 days. And because the other 5 days don't fit in, they simply declare it as a festival period. So the Sumerians seem to have done the same thing for the days on the day Amavasya or the day after. They have dropped that. So they came up with a 4-week period. The week ending of the week, half present, full present, half present, and the Amavasya of some sort. They have this thing. And they eliminated the middle period from that. The 2 days they skipped it. So you can see the 4 times 7 section celebration coming. But for some reason, it's the original context is gone and this context has come, and we are not skipping the middle period, the 1.5 or 2 day period in between. What other values? That's the only explanation I have seen for the origin of the week. The week that we celebrate, or the week that's listed Sunday, Monday, Tuesday, Wednesday, or Friday, Saturday, Sunday, is not necessarily the origin of the order of the original week also. The Greek and Romans apparently they did it in the order of the planets or something. From the Earth, the closest is the Moon. The next closest is Venus. The next is Mercury. Then the Sun. Then Mars. Then Jupiter and then Saturn. And think about the days related to that. That was the order they once had. The week had that order. For some reason, the Sun became primary, perhaps because the Sun is the primary god for most cultures. So it starts with the Sunday or ends with the Sunday. Here, the Jewish order of the Sabbath beings. All kinds of complexities are found. In every thing, some complex factor or the other will come in, and then think about the Yuga. What is the Vedic Yuga? What is Brahmaputra's Yuga? What is this gentleman? Aryabhatta is happily redefining his own Yuga. I start this. We have our calendars, Julius Caesar. Their Roman calendar, he said, I am Caesar, I want an extra day, I want to change my month. Boom, done. There is, even today, there is, I think, there is president of Kazakhstan or something, whose name Thursday after his mother and 1 month after himself. So this is not in fact.
Long before. March was the beginning of the year. Later it was changed to January. January was the beginning of the year. Is there any reason for that? What are the reasons of the change?
You can make one guess, and it's supported by something I read in the New York Times article recently.